Hi, this is Surely Physics. I'm just getting you started on linear motion practice E number 3. We have a tennis ball being thrown vertically upward with an initial velocity. So there's someone who's kind of standing on the ground here, and they take a ball and throw it up. So what's it going to do? Of course, it's going to come to a point at the top where it's going to start coming back down again and eventually come down to the ground. So if you ever take an object and you toss it upward, you ever notice that when you toss it up, it comes down at the same speed at which you toss it up? Or if you jump up, you hit the ground at the same speed as with which you jump. If you want to do a little test on that, just take a little hop and you'll feel your weight kind of come down when you land. And if you jump up really high and then come back down, you feel like you come down harder. So when you hit the ground, you're coming back down faster. So however much force you push yourself up with, that's the amount of force that you feel when you hit the ground. This also relates to the speed. The faster you jump upward, the faster you hit the ground. So if a tennis ball is thrown upward with a starting speed of 8 meters per second, this is really a conceptual question, part A. Let me zoom in on my little dude there. Okay, tosses it up with 8 meters per second of speed. What will be the ball speed when it turns to its starting point? So when we get down to this, back to the same level, it's going to be right here. It will have gone up to the top, and then it starts going back down. So it's going up here, but here it's going back down, and it's going to be at some speed there when it returns that starting level. What speed is that? It's just 8 meters per second also. But when you work this into a problem, keep in mind that if you call up positive, then the starting speed, the starting velocity, is a positive 8 meters per second. But the final velocity is going to be 8 meters per second down. So we will want to call that a negative 8 meters per second as the final velocity. Now there's one more thing you want to consider here. What is that implied acceleration due to gravity? If you're like, oh, that's 9.8 meters per second squared, you're exactly right. But which direction? Up or down? In this scenario, we're not just dropping like a flower pot onto the ground. We're tossing a ball upward. So why does it get slower as it goes up and faster as it goes down? Because the acceleration due to gravity is down. As it's moving up with a positive velocity, there's a negative acceleration that makes it get slower. So that at the very tippy top, what is that speed at the top? That velocity? It's 0. And that's also one of the implied bits of information for one of our next problems. At the very top point, the velocity is 0. So that means it slows down from 8 meters per second to 0, and it speeds back up to 8, but in the negative direction, to a negative 8. So these are your pieces of information you're going to need to finish this problem. Good luck.